finding that system of 2x2 linear equations. So I'm looking for two kind of y equals mx plus b sorts of things. Now, the first part here, part A, has asked us to find a system, a 2x2 linear system that has exactly two solutions. So what does it mean to be a solution to a linear system? Thinking back to our maybe pre-calc or algebra or geometry skills, if I have two equations of lines, so let's say there's a line and here's a line, then the solution to this system is the point of intersection. So that would be my, oops, can't spell solution today. It's a solution. That's what the solution to that 2x2 system would be. So in fact, we can't write a 2x2 system with exactly two solutions. Exactly two solutions would mean somehow I had two lines and they intersected in two places. The only way to do that would be to kind of like bend this over, or for my two lines to actually be exactly the same. But if our two lines are the same, they don't have two solutions, they have infinitely many solutions. Now let's look at B. So the next thing here is that we need a 2x2 system with no solutions. And I'll just put an X through that one because we can't do it. No solutions, that one we should be able to do. Now graphically, that's going to look like I have two lines, but in order to have no solutions, they can't ever cross. And the only way I know of to make two lines that don't cross is to make them parallel and give them different intercepts. So we just needed any example. So I'm going to keep my life easy and say y equals 2x, and then I need another equation with the same slope. So how about y equals 2x plus 1? So that's going to be a system with no solutions. Next, let's think about a system with exactly one solution. So that's actually like the first one that I drew up there. To have exactly one solution, I'm looking for two lines that intersect. And it's actually pretty easy to make two lines that intersect because the only thing we have to do is make sure that they do not have the same slope. So as long as they don't have the same slope, they should intersect. So how about y equals 2x and y equals 3x? Just keep my life easy. Now, our next piece here, if I'm looking for infinitely many solutions, and I kind of alluded to this one before, but the only way to have an infinite number of solutions, if I have two lines, is if secretly those two lines are actually the same line. So if I think about what that would look like as two equations, maybe I could write the first equation as y equals 2x plus 1. But if I write the second equation as 3y equals 6x plus 3, then really these are describing the same line. And that's what's been happening when we've been looking for those eigenvectors, is when we write out the linear system, we end up with two equations that secretly are the same line. Now, E has asked us to find two systems that have only the trivial solution. And that trivial solution means the point 0, 0. So it means I'm looking for two lines that both go through the point 0, 0. And it turns out that my example for exactly one solution can also work for only the trivial solution, because y equals 2x and y equals 3x both go through the origin. And our last piece here, we want it to have has no zero solutions. No zero solutions. Well, this means it has to have a solution, but I don't get to use the one that where the solution is 0, 0. So if I don't get to use the solution where it's 0, 0, I'm going to go maybe y equals 3x, and I just need anything else that does not have the same slope.